Good afternoon, students. Today we are going to start a chapter vectors, right? There are mainly two types of quantities we see in our daily life. What are they? Say volume, okay, mass, time, speed, okay, and so on. A lot of things we see in our daily life which has only values, that is you can measure the volume by cubic centimeter, cubic millimeter, cubic kilometer, this way, mass, okay, time, second, minute, hour, only the value you can measure, right? Speed, also only the value we can measure, like this. There are also another quantities like weight, velocity, okay, velocity, acceleration, momentum, and so many things, okay. Displacement, okay, here also distance, we see a lot of things we see, but here in case of weight you will get the value, how much weight, and also a direction, weight towards the earth, okay. Velocity, you will get a direction, in which direction the velocity is, okay. Acceleration, momentum, there also a direction. Displacement will get a direction, okay, but here also only the values. So the quantities only values, with only values is called the scalar quantities, right? And the quantities which has values as well as the direction, okay, both, that is, these are called vector quantities. Vector quantities, and these are called scalar quantities. Vector quantities and scalar quantities, right? So you see distance, say here is a point A, here is a point B. You can go from A to B this way also, going this way. By this way also you can go from A to B, right? You can go directly to this direction. So it is the what? These ways are, if you measure the total line, total path, you will get the distance from A to B, but it is not the distance directly, but it is the displacement from A to B towards B. Here is a direction. So this is not vector, this is vector. So you can say also, what is vector? A directed line segment is called a vector. Clear? So what is the vector here? From A to B. How will you write? A, B, overhead arrow, A to B, and A is called the initial point and B is called the terminal point, or you can say it is the tail, it is the head, right? So you will write an overhead arrow AB. You can give A also this way, say it is the vector A, small a, this way, okay. So how will you write a vector? A directed line segment, say A to B, this way. Say this is also. So how will you write? A, B, like A. This is called a vector. A directed line segment which will distance, the value and the direction. So how will you measure the distance from A to B? By tape or whatever scale, ruler, whatever be. Then the length is called the magnitude or modulus of the vector. This one, magnitude or modulus. How will you measure? How will you denote? This by modulus sign. This is equal to magnitude or modulus of a vector. That is the length of that vector. Okay, and the direction from A to B. Clear? This is called magnitude and or modulus of a vector. There are some kinds of vectors, some definitions. I am explaining one by one. Follow it. A vector from A to B if its magnitude be unity, that is, if the modulus be equal to 1, then the vector AB will be called unit vector. Okay, the length of a vector if b equal to unity, that is 1 unit, then the vector is called the unit vector. If the initial point and the final point same upon the same point, that is there is no value, that is distance is what? 0, that is the vector A. Understood? If this equal to 0, then this vector is called zero vector or null vector, right? That is special symbol O overhead. It is called zero vector or null vector. Clear? What are equal vectors? Consider two vectors. If the two vectors, consider A and vector B, two vectors have the same sense means direction, same direction, and the magnitude also equal, that is length also equal. For the two vectors, the such types of vectors are called equal vectors. Their sense will remain same and the modulus, that is magnitude, will remain also same. That is vector this equal to vector B, then you will say vector A is equal to B, same vector. Okay, and the vectors, at least one thing, say these are the vectors. Are they? If the modulus also same, but the direction are the same. Direction same? No. So these are not the equal vector or same vector. These are unequal vector, right? Consider a vector A to B. Say A, it is from the point A to point B, direction from A to B. So what will be the vector A? BA. BA will be in opposite direction. This is denoted by this way. That is, if the direction be opposite, it is called the negative vector of the vector this. Right? In opposite direction, this is called negative vector. Right? If the initial points of some vectors, two or more vectors, remains unique, there is same. Say these are two vectors or three vectors, A, B and C vectors. Say O, it is A, it is B, it is C. The initial points here, come on, O, fix. These are called co-initial vectors. Initial points same, or whatever be the terminal points, may be separate, but initial points are same here. Such types of vectors are called co-initial vectors. Okay. Now come to what are collinear vectors. The vectors giving the same support A, say B, here say C. AB vector, BC vector here, same support. These are called collinear vectors. If, here see one thing, if you can express say AB in some scalar multiple of BC, vector AB, here what is this symbol? Can you tell me? What is the name of this symbol? Yes, the name of this symbol is lambda. Lambda. In physics you will get lambda, right? If you can express the vector AB in some scalar multiple of BC, then you can say the points A, B and C are collinear points. Are collinear points. We'll do later when I will try to solve the exercise. So these are collinear vector and the collinear points. By using vector method, we can prove the points are collinear or whether the points are collinear or not. Now come to like vectors and unlike vectors. If the direction of some vectors remains the same, magnitude may not be same, may or may not be. These vectors, say it is A, it is B and it is C vector. All directions are the same way, sense are same. These types of vectors are called like vectors. If there be a vector in opposite sense, are these two like? No, these are called unlike vectors. Clear? So, like and unlike vectors already learned. The vectors lying upon a same plane, you can treat the board as a plane. So all vectors here upon this, all vectors are lying upon what? On this board. So such types of vectors are called coplanar vectors, that is lying upon the same plane or parallel plane. They are called coplanar vectors, right? What are free vectors? If the vectors, the initial points are not defined clearly, such types of vectors are called free vector. That is, the initial point of vectors are not defined clearly. Initial points of a vector not defined. These are called free vectors. Clear? Now come to a very important part. Position vector with respect to some fixed point. Consider a point A, this, and here is a point O. Okay. OA is the vector here. Okay, it is a vector with respect to a fixed point. This fixed point is called origin. With respect to this origin, here is O. For the point A, OA is the position vector for the point A. That is, you can determine the position of a particular point on a plane by using position vector. Okay. So OA is the position vector, that is here is what? A. For the point A with respect to the fixed point O, O is called the position vector. What are parallel shift? What are parallel shift? That is, you consider a vector here. Okay, draw in some distance a parallel line to this line. Then you can shift it here directly. That is the same support, same length. That is here this length, here this length, this length. If the vector be A, here this vector also will be A. It is called the parallel shift of a vector. Very important. Parallel shift of a vector. If you consider a vector here from A to B, okay, so you can shift this vector upon a parallel line. So here is A and here is B. If the name of the vector be C, then here is also will be C. This is called the parallel shift of a vector. According to requirement, we will shift vectors for calculation. Okay. Now come to addition and difference of two vectors. This is vector A, say this is vector say B. How will you find the sum of these two vectors? Shift this vector parallel, draw a line here, shift this vector here, here. So these will be the vector what? B. These are called parallel shift, already you learned. Okay. Now join this, another vector say C. Already it is a triangle. Assume a force is going through this point, say from C to A and from A to B. These are the directions. Okay. And there is another vector C from C to B. It is neutralizing the force. You can assume this way. And clearly, this plus this, the total force, that is B plus A, will be equal to C. This is called the triangle law of vectors. Okay. These are the sum. The sum of these two vectors A and B is giving the another vector C, right? So, if we consider the vector A in opposite direction, see, of course, it will be negative of A. Okay. Opposite direction. Draw another vector, say B vector. So, of course, this force neutralizing this vector, that's you can write B plus minus A equal to D vector. This implies vector D equal to B minus A. So, this is the difference of two vectors, this is the sum of two vectors by using triangle law, triangle of vectors, right. How will you represent a vector AB with respect to the position vector? Say here is the point A, here is the point B. The vector is from A to B. So what will be the vector AB? How will you write? With respect to the position vector. How will you write? Consider a fixed point O. Join and join this also. Say OA is equal to vector A and OB vector B, right? So already learned the triangle law. Consider the force is going this way, and these vector neutralizing the force. Triangle law. So what is this? A vector, that is OA plus AB equal to OB, right? This implies OA, O is equal to A vector plus AB is equal to OB. OB means B vector here. So this implies AB equals to vector B minus vector A vector. Write down this. This is a formula with respect to the position vector. So AB vector will be what? Vector B minus vector A vector. Copy it. Now Will I continue? Now come to components of a vector. How will find the components of a vector? Okay. First draw a three-dimensional figure, coordinate axis. So it is x, it is y, and it is z, where origin is O. Okay. Along the vector OX, unit vector is I, OY, J, and it is K. Okay. Along the axis, consider a point P here. The coordinates x, y, and z. Join OP. So it is R vector. So what will be the OP vector? OP here, R vector. Write down it. This is the formula. You can write. It is xi plus j plus zk. All are kept. Here kept is the unit vector. Special notation for unit vector. For unit vector, write it down. So if A is the unit vector, it is defined by the vector A and divided by modulus of the vector A. A cap means unit vector, A is the unit vector, and all I, J and K are the unit vectors along the axes. So the Z axis, X axis and Y axis. So here Xi, Yj and Zk simply called the vector components of the vector R, and X, Y and Z are called the scalar components of the vector R. Write it down. So already you learned components of a vector. Draw this three-dimensional figure again. It is x, it is y, and it is z, and the point P, x, y, z. Okay, it is vector R. OP. So OP is given by vector R is equal to xi, already you wrote, plus j cap plus z and k cap, right? So what is the modulus? There is a magnitude of the vector OP. How will you find magnitude of OP? OP vector is equal to modulus of R vector. Write down this formula: square root of x square plus y square plus z square. This is another formula of finding the modulus or magnitude of a vector. Write it down. After that, a very important thing for a vector. It is z axis, it is y, it is x, right? Draw a box. Okay. Draw it first like me. This is origin, that is O. Now consider this point as P point. Join OP, that is vector R. Okay. What is the coordinate of the point P? X, Y and Z. Clear? And the vector OP making angles with the x-axis alpha, with the angle y-axis beta, and with the angle with the z-axis say gamma. I am telling this again. The vector OP making an angle alpha with x-axis, beta with y-axis, and angle gamma with the z-axis. Okay. These angles alpha, beta and gamma are called direction angles of the vector OP. Clear? These angles alpha, beta and gamma are called the direction angles of the vector OP. Okay? Clear? And cosine of the angle, that is cos alpha and cos beta and cos gamma, cosine of the angles is called, cosine of the angles called what? Direction cosine. Direction cosine of the angle, that is cos alpha, cos beta, cos gamma are called direction cosine of the vector OP, and it is denoted by cos alpha equal to L, cos beta equal to M, and this equal to N. That is L, M and N are called direction cosine of the vector OP. Clear? I am telling this again. The angles alpha which are making with x-axis, beta making with y-axis and the gamma with z-axis for the vector OP are called direction angles. Okay. And the cosine of the angles, that is cos alpha, cos beta and cos gamma are called the direction ratio of this vector, denoted by L, M, N. Clear? Okay. This is a very important relation between L and M. What is this relation? L square plus M square plus N square equal to 1. That is sum of the squares of the direction cosines will be equal to 1. Clear? Sum of the squares of the direction cosines of this vector will be equal to 1. Very important relation. Right? We will prove this later. Before going to that, there is one important thing. The numbers which are proportional with the direction cosines, that is with L, M, N. The numbers which are proportional with the direction cosines are called direction ratio. That is, if A, B, C are the numbers which are proportional with the direction cosines, that is A by A, M by B, N by C, then the numbers A, N, B and C are called direction ratio of the vector OP. That is all. Clear? That is one thing. You can write this root over of L square plus M square plus N square. Do you know how? Already you learned this, already you got in class 10 in ratio proportion chapter. The chapter ratio and proportion, you got this, how to write this. Okay. Already you know, I told you the upper part is what? 1. 1 by this part. So what will be L here? L will be this equal to 1. I am writing it here clearly. When you will write a square, of course you will give plus minus. Okay. It will be plus minus square root of a square plus b square plus c square, and upper portion is 1. So what is L? Plus minus a by root over of a square plus b square plus c square. What will be m? Write down all this formula. It will be needed in solving. A square plus b square plus c square, and similarly n. Write down yourself. Okay. These are the relation of for finding the direction cosines when direction ratios are given to you. Very important formula for this one. Okay. So today, after this, in next class we will prove first this relation L square plus m square plus n square equals to 1. After proving this formula, that is the sum of the square